Now, the important concept or the important topic of the unit, we are talking about the forward chaining and the backward chaining in the AI. And for what purpose we are talking about here the forward chaining and the backward chaining? We must have talked about the basic concepts in a knowledge base and the representation that what is the knowledge, what is the reason, and what is the inference. So, what is the reason in a or the reasoning in the AI? Simply here we are talking about the various inference techniques here, the forward chaining and the backward chaining. So what is the reasoning and what is the inference? We should understand first before understanding forward chaining and the backward chaining. So what is the reasoning? Reasoning involves the analysis of information, or reasoning involves the analyzing the information, then identifying the patterns, and then apply logical rules to draw the conclusion from the data. So then we are talking about the capturing of a knowledge or capturing of a data or representing of a knowledge in a system. After the knowledge acquisition, after the data capture, reasoning as a process should be run in artificial intelligence, and this process involves the analyzing of the information. Whatever the insights we are getting from the data, that should be properly analyzed. We should identify the patterns and apply the logic rules to draw the conclusion. What, who should do this? The system in which we are implementing. And inference and action. Here we are talking about the inference. Inference is mean once reasoning has been done. जब रीजनिंग आपका प्रोसेस कंप्लीट हो जाएगा एंड रीजनिंग के प्रोसेस में व्हाट वी आर टॉकिंग अबाउट एनालाइजिंग, identifying and applying the various logical rules. If when the reasoning has been done, the system should use its derived knowledge to make the predictions, now the future predictions, or to take the decisions based on a new data. So what is the reasoning? In artificial intelligence is simply reasoning, basically a process which draw the connections between the data and do the predictions between various data. And what is the inference? The process that is trained by a various machine modeling algorithms or the machine learning models that is used to draw the conclusions from the brand new data when the data has been changed, right? So here we are talking about the forward chaining and the backward chaining in AI. Before that, we are talking about the inference engine here. So first, what do you mean by the forward chaining, or what do you mean by the inference engine? Inference engine is the component of an intelligence system in the artificial intelligence. So it is another component where we are talking about the actions need to be performed on the new data, which applies the logical rule to the knowledge base to infer a new information from the from the known facts. So here, what we are talking about, what is the important term we are talking about? We're talking about the inference engine there. It applies logical rules to the knowledge base to infer a new information from the known facts. जो पहले से data है, the history of a data, to discover a new information from that data, or simply a data discovery will be performed here. The first inference engine was a part of an expert engine. Inference engine commonly proceed in two modes, which are the forward chaining and the backward chaining, right? So what is the forward chaining and the backward chaining in the artificial intelligence, all in the inference engine? Simply forward chaining in artificial intelligence with the help of a forward chaining means moves from the fact to the conclusion, right? Different facts has been there. From different facts, we will move from a facts to a conclusion. While in a backward chaining, we are saying that we will move backward from a conclusion to find the facts that can support a particular conclusion. Simply as we do in a mathematical algorithms in a proving of a system or to prove any algorithm, what we do first, we say that let's say this, it will be approved or it will be proved. And after specifying the different, after explaining or analyzing the different steps by which the algorithm can be proved or can be proved, that means we are talking about from we are talking about the backward chaining. We are moving backward from a conclusion. We had already said the theorem has been proved to find the facts that can support that proof, right? That can support that conclusion. So here in the forward chaining and the backward chaining, both are the reasoning methods here, which is used to design the inference engine component of AI expert system. So what do you understand by the inference engine? It is a software component, or it is simply, it is a software component of artificial intelligence that use the various logical rules to analyze the data and make the conclusions. So first we will talk about the forward chain. So let's talk about the forward chaining first. What do you understand by the forward chaining? Forward chaining is known as the forward. What is the formal definition of a forward chaining here? Is known as the forward deduction or the forward reasoning method when using an inference engine. Forward chaining is the form of a reasoning which start with atomic sentences in the knowledge base and applies the inference rule in the forward direction to extract more data until the goal is achieved. So simply here we are talking about, we will go from the facts, right? And we will move from the facts to the conclusions. We will start with the atomic sentences that are already in the knowledge base and apply the different inference rules or the actions in the forward direction so that the goal will achieve or the more data will be extracted from the existing data. So the forward chaining algorithm, if we are talking about the forward chaining algorithm, it starts from the facts, triggers or the events or rules whose premises are satisfied and add their conclusions to the known fact. Or simply this process repeats until the problem is solved. So what is the property of a forward chaining? It is down-up approach because from a child we are moving to the root as it moves from bottom to the top. So first property here we are talking about, it is a down-up approach. It moves from bottom to top. Another, it is a process of making conclusion based on the non-facts or the data by starting from the initial state and reaching the goal state. Simply, forward chaining is also known as the data-driven as we reach to the goal using the available data. So simply here we are talking about forward chaining. Now what are the applications? In application we are talking about it. We are talking about the application of the forward chaining approach is commonly used in the expert systems such as the CLIFS business and the protection rule systems. What is the CLIFS here? It's a contrastive language or the image pre-processing language. Here, simply, it is a method of learning from the natural language supervision, and it is simply a learning from the natural language supervision systems, right? So here the forward chaining approach has been used. Now let's consider with the example what is the forward chaining. Here we are talking about a first order logic also, the facts conversion into first order logic. Now here the fact is given that it is a crime for an American to sell the weapons to the hostile nations. So let's say here we are talking about the different variables in the first order logic. P, Q, and R are the variables here. P stand here for the American here, Q for the weapon here, and P, Q, and where here simply we are talking about the various quantifier, and we are saying that the universal quantifier, the American, the weapons, and the CS P, Q, R hostile are termed as the or which implies as a criminal here, right? So country A has some missiles, right? P owns a missile here. It can be written in two definite clause by the extensible installation, including a new constant here, or simply we are talking about how we can define this statement. So missiles here we are talking about all of the missiles were sold to a country A by the robot. Here we are talking about. Now all of the missiles has been owned by the country A was saved by the robot, right? Now missiles are the weapons. Now we are saying that the missiles are the weapons. Missiles are the weapons. Enemy of America is known as a hostile, right? Here we are talking about. So enemy of America is a hostile. Here we are identifying the country A is an enemy of America, right? So simply it implies that the country A is the enemy of America. Now enemy here, America, Robert. So who is the Robert is an American. Other we are saying that Robert is an American. So Robert is an American. So these are the statements we have identified. Now, what is going in our first step? What we have talked about, the forward chaining proof is that the Robert is an American. So in the first step, we will start with the known fact and will choose the sentence which do not have the implication, such as American, Robert, enemy, America, own, even, and missile, even. All these facts will be represented as here. Now, at the step second, we are talking about at the second step, we will see those facts which infer from available facts and with satisfied premises. Rule 1. The rules we have talked about here, these are the different rules that we have talked about, right? So according to that, in a step 2, at the second step, we will see those facts which infer from the available facts. What are the available facts? And with satisfy premise. Rule 1 does not satisfy the premise, so it will not be added in the first equation. Rule 2 and Rule 3 are already added here, and Rule 4 satisfy with the substitution here. So it will say Robert is added, which infer from the conjunction of the Rule 2 and the 3, and the Rule 6 is satisfied with the substitution. So the hostile A is added, and which infer from the Rule 7. So here simply we are talking about the weapon, the missile sale, own, whose owns, and that is the hostile will be the enemy of America. These two figures has been achieved by this. In the step 3, we are talking about, we can check the rule 1 is satisfied with the substitution here. What substitution we are doing? The robot, 2 with the T1, R with the A, right? So here we are talking about, so we can add the criminal as a robot here, which infer all the available facts, and hence we reached out our goal statement. Who is the enemy here? Who is the criminal here? The robot is a criminal because hence it is proved that the robot is a criminal using the forward chaining approach here. We have used the forward chaining approach. Or simply we can say with the known facts that the American robot is American, it's a missile, owns, and the enemy. With that, we are talking about missile is a weapon. Missile is sold by a robot, right, who owns it, and it is hostile enemy, hostile, whoever is the hostile, that will be the enemy of America. And with all these inclusions, that Robert is an American, so it is a criminal also, it has a weapon also, sales to the hostile. So all these has been situation proved that the Robert is a criminal. So it has been proved that the Robert is a criminal using a forward chaining approach here. Or simply we can take another example also. here another, the same thing I am showing here with the another conversion here. So facts conversion into a first order logic. First is it is a crime from an American to sell a weapons to the hostile nation, and simply we are representing it with three variables P, Q, and R, right? Or simply here we are saying that country A has some missiles, right? P owns A P some missiles, right? Some missiles with the extensible here it can be written in two definite clause by using the extension installation and introducing new constant T1 also. Here we have written that, right? Then all of the missiles were sold to a country A by the robot only. कंट्री ए के पास कुछ मिसाइल्स थी, वो सारी मिसाइल्स किसने उसको बेची, रॉबर्ट ने बेची. So then we have another rule here, right? So now here the missiles is a weapon. Missiles are the weapons are there. So we have found another rule that missiles are the weapon. Then we have another rule. Enemy of America is known as the hostile. So an enemy जो है अमेरिका के वो hostiles हैं. Another rule is there. And country A is an enemy of America. Another fact is that country A जो है वो enemy है अमेरिका. तो obviously वो hostile है. रॉबर्ट इज एन अमेरिकन, और रॉबर्ट जो है अमेरिकन है, लेकिन रॉबर्ट ने ही मिसाइल्स बेची हैं किसको, जो उसकी कंट्री की एनिमी थी. ठीक है, तो हियर द कंक्लूजन वी हैव गॉट फ्रॉम द फॉरवर्ड रीजनिंग दैट द रॉबर्ट इज अ क्रिमिनल हियर. Again, you can see here with the first step that in the first step we will start with the known fact and we choose the sentence which do not have the implication such as Robert is an American, right? Country A is an enemy of America and it owns some missiles here. T1 is a missile here and country A owns some missile here. Robert is an American missile. T1 is a missile and T1 is owned by a country A and the country A is the enemy of America. Simply with these known facts, we another conclusion that at the second step we will see those facts which infer from the available facts and with the satisfied premises of a rule one does not satisfy the premises, so we will not add in the first here, simply iteration, and the rule 2 and 3 are added here. Rule 4 satisfy the substitution here that it is a missile here, so we will say that the robot sells the missiles to the country is added here. So now we have added T1 is a weapons and Robert had sold that weapon to a country A and that country A is a hostile of America here, right? So simply in this step we have seen that another conclusion that missile and it owned by A and that missile has been sold by a Robert. So with these conclusions we have got the that we can add another node which is a root node as a criminal, that Robert is a criminal, and hence we have reached to a goal state here. So hence it is proved that the Robert is a criminal using the forward chaining. Now we have discussed about the forward chaining. Now what is a backward chaining? Simply we will move back to the definition of a backward chaining. Backward chaining, horn clause or a definite clause, right? In a backward chaining, we are talking about a horn clause and a backward clause. Now, what's a horn clause and the definite clause? They are the form of the sentences which enable the knowledge base to use more restrictive and efficient inference algorithm. Now, the horn in a backward chaining, we are talking about also the horn clause and the backward in the chaining methods we are talking about in the reasoning methods, in the inference method, we are talking about the horn clause and a definite clause. So these are the forms of a sentence which enable the knowledge base to use the more restricted and efficient inference algorithm. Logical inference algorithm use the forward and the backward chaining approaches, right? Which require knowledge base in the form of a first order definite clause. That's why we have taken an example of a first order definite clause here. Now, what is a definite clause? It is a clause which is a disjunction of literals which with exactly one positive literal is known as a definite clause or a strict horn clause. Now, what's a horn clause? Which is a disjunction of the literals with at most one positive literal, right? The difference is exactly one positive in the definite clause and in the at most one more, not more than one. At most one positive literal is known as a horn clause here. Hence, all the definite clause are horn clause here, right? So it has only one positive literal, K, and it is equivalent to that P, Q implies K here. So simply we are talking about the definite clause and the horn clause in a inference engine chaining method or in a or simply in another way what we can say about a definite clause is a type of a horn clause that has exactly one positive literal. It is used to represent a knowledge in a rule based reasoning system, and basically the definite clause we use in the forward chaining algorithm to drive the conclusions from the known fact, and we use it to solve the problems like proving that someone is a criminal. Here we have seen it, and it can also be used in the language analysis here. Now, what is a horn clause? Horn clause basically we are talking about here a formula that can be used in artificial intelligence to represent the knowledge and perform the inference here. And horn clause are the fundamental part of our logic programming here. And here, when we are talking about the positive literal, here we are saying that the positive literal here is the head of a clause, and the negative literals are the called the bodies here. So here we are talking about the backward and the forward chaining also, or the deduction also. Or here we are using it in a backward chaining also. So what is a backward chaining now? Another approach we are talking about is in an inference engine is the backward chaining. Backward chaining is also known as a backward deduction or backward reasoning method. When using an inference engine, a backward chaining algorithm is a form of a reasoning which start with the goal and work backward chaining through the rules to find known facts that support the goal here. So what are the properties or how it is different from the forward chaining? The property is that the backward chaining is a top-down approach and the forward chaining is the bottom-up approach. Backward chaining is used in the modus ponens inference rule. In backward chaining, the goal is broken into a sub-goals or the sub-goals to prove the facts are true. Or simply we are talking about it is called as a goal-driven approach, as a list of a goals decides which rules are selected and used, and the backward chaining algorithm is used in game theory, automated theorem proving tools, inference engines, proof assistants, and various AI applications. The backward chaining method mostly use depth first search strategy for the proof. So these all are the properties of a backward chaining. Now here we are taking an example of a backward chaining, the same example we are talking about. In backward chaining, we use the same above example and we will rewrite all these rules. We are saying that again, American weapon as a Q, spell PQR, A hostile R, criminal P, owns AT1. The same rules here we are talking about. Now how the backward chaining will do. In backward chaining, we will start with our goal predicate that criminal is a robber and then infer further rules. So at the first step, we will take the goal fact, and from the goal fact, we will infer the other facts. And at last, we will prove those facts true. So our goal is that Robert is a criminal. We need to prove that the Robert is a criminal here. So falling is the predicate for it. What predicate we are talking about? First, we are talking about that Robert is a criminal. So at the second step, we will infer other facts from the goal facts which satisfy the rules. So as we can see in rule 1, the goal predicate criminal Robert is present with substitution Robert as a P. So we will add all the conjunctive facts below the first level and we will replace P with a Robert here. So what facts we have find? So we can see American. First we can see that Robert is an American. So it is proved here, right? Then we see that as a weapon, has sailed by a Q is a weapon, which is sailed by a Robert to the R and R is a hostile. These are the known facts. That R is a hostile, weapon is a Q, and P has sailed that weapons to the R and R is a hostile here. So in the second step, we have concluded this. At the step 3, we will extract further fact missile. Now missile will be there, which is Q, which infer from the weapon Q. So we have extracted another information from the weapon Q that weapon Q is a missile. So which infer from the weapon as it satisfies the rule 5. So we say that weapon Q is also true with the substitution of a constant T1 at the Q, and we are substituting missile as a T1. Now in the step 4, we are saying at the step 4, we can infer facts T1 and owns a T1 from the cell Robert T1 to R. So here we satisfy that the rule 4, here which satisfies the rule 4 to the substitution of A in place of R, which is the hostile here. So two statements are proved here. What? That T1 is a missile, whatever has been that because Q was sold by a Robert to the hostile R and Q is a missile, so we can say that Robert has sold that missile to the hostile, right? And that missile was now owned by a country A. So at step 5, we can infer the fact that A is a America enemy. So here, who owns the now missile here? The country A, and country A is the enemy of America from the hostile A, which satisfy the rule 6. And it, with the help of this all statements, the all statements have been proved using a backward chaining, and we get the proof that if the Robert has sells these missiles to the country A, and country A is the enemy of America, so definitely Robert is a criminal. So hence proved. So what is the difference between a backward chaining and the forward chaining? Simple. So forward chaining starts from the known facts and applies inference rule to the extract more data unit it reaches to the goal, right? So simply we are talking about we are reaching to a root node, or we are from the sub nodes or from the sub modules we are reaching to the root node. So simply the forward chaining is a bottom up approach here. In a backward chaining, we are saying that backward chaining starts from the goal and work backward through the inference rule to find the required fact that support that goal. Like in the backward chaining, first we have seen in the root node that the Robert is a criminal. How can we say that the Robert is a criminal? We will now search, or the AI or the inference engine will search for that fact. How it is possible that the goal is to support a goal. Now it will search the another facts to support the goal here. So simply backward chaining is a top-down approach and forward chaining is the bottom-up approach. Now forward chaining is known as the data-driven inference technique as we reach to the goal using the available data. So simply we are saying that forward chaining is known as a data-driven inference technique as we reach to the goal using the available data. So it's a data-driven data-driven inference technique. And in a backward chaining, we are saying that it is also known as a goal-driven technique, as we start from the goal and divide into a sub-goals to extract the fact, to prove that goal. In the fourth difference, we are talking about that forward chaining reasoning applies a breadth first search technique. So we have talked about in a unit 1 about what is a breadth first search technique for the strategy. And in the backward chaining also we have talked about that the backward chaining reasoning applies a depth first search technique. So both the search techniques, that are the uninformed search techniques, we have talked about in the unit 1, and simply the difference is BFS and the DFS. In form of a forward chaining we are talking about the BFS, in the backward chaining we are talking about the DFS. Another difference is that forward chaining test for all the available rules. Simply, when we need to test all the available rules, the forward chaining test all the available rules, but the backward chaining only tests for the few required rules that can prove a goal, right? Or that can support a goal. So forward chaining need to test all the rules, but backward chaining need to test only the required rules. Now forward chaining is suitable for planning, monitoring, controlling, and interpretation the applications. But what backward chaining is suitable for the diagnostic, for prescription, and debugging the applications. In the forward chaining, we are saying that forward chaining can generate an infinite number of the possible rules, right? Or it can generate the infinite possible conclusions, because here the goal is not there. We can have the number of data can be derived from that. From the existing data, we can derive the number of conclusions, but the backward chaining will focus on a finite number of possible conclusions, because we know what we need to search out, right? So here in the backward chaining, we know that what we need to search out based on a goal statement. So simply it will give us or it will generate a finite number of possible conclusions, and the forward chaining can generate an infinite number of the possible conclusions here. So another things, it operates in the forward direction, right? And it operates in the backward direction, that is simply the top down in the bottom up approach. Forward chaining is aim for any conclusion, and backward chaining is only aim for the required data that need to be used for a particular conclusion. So this here we have talked about the forward chaining and the backward chaining, right? We have talked about the inference engine, right? Now, so can anyone, another topic we need to discuss about the probability notation here. First, we will see the syllabus of our second unit, which has been completed. So this is a syllabus here. So in our second unit, we just need to understand about the knowledge representation issues and the techniques. We have talked about the predicate logic. We have talked about the knowledge representing knowledge using the rules, semantic nets, partition nets, frames, forward and the backward chaining, and the frame-based systems. We have talked about this.